All right, this section we're looking at combinations of functions and compositions. And just to start out, we're going to look at being able to find the domain of a function. All right, and key things that you're looking for here is what might cause the denominator of a fraction to be equal to 0, making it undefined. So those are things you have to exclude from your domain. And then also what would result in you taking the square root of a negative number. That is also something that you would have to exclude from the domain of your function. So looking at this first one here, we have a quadratic function. X squared minus 7x is just a quadratic. And if we remember back, quadratics in general have that U-shape pattern to their graph, that parabola shape. And so if we're talking about x values here, if this is going to continue to get wider as it goes to the left and to the right, as it goes to the left, that means it's going towards infinity, and as it goes to the right, that's going to infinity. So our domain, and this is for pretty much any quadratic function, is going to be negative infinity to infinity. This next one here, this is a rational function, all right? And this is going to be one of those cases where you're going to have to look at what could cause division by 0. Because if it causes to be divided by 0, that makes it undefined. And those would be values you would have to exclude from your domain. So we're going to focus here strictly on the denominator of this function. And we're going to factor it. So we need to come up with what are two numbers that if we multiply them, we get -3. And if we add them, we get -2. All right, let's see. I believe that would be a -3 and a +1. All right, if then I take each of those and I set them equal to 0, this is going to tell me what values of x make this function equal to 0. So that would be x equal to 3 and x equals -1. So those are the values that I have to exclude from my domain. So it cannot be, it can be pretty much any x values except for those two right there. So if I start here on the left, this is go from -infinity, right? Looking at these two values, the smaller of those two is -1. So -infinity, -1, union, -1 to 3, union 3 to infinity. And so we excluded what values make that equal to 0. Okay, this next one here, we're looking at, this is a square root. So this is going to fall into that case of what might possibly give us a square root of a negative number, right? Which we can't do. We want to stick to the real numbers. So in this case, we need to figure out what makes this part that's underneath this square root, what would possibly make it negative. So we're going to take what's underneath that square root, and we're going to say we need it to be greater than or equal to 0, right? Basically, we need it to be not a negative number, all right? So let's see, if we solve this, I'm going to subtract 12 and then divide by 3. And we need this to be any value, right, that is greater than or equal to -4. Right? We need any value that's going to be greater than or equal to -4. So our domain here is going to be bracket, because it's equal to -4 to infinity. Right. And our next one, here we've got another rational, and it's got a radical in the denominator. So it can't just be, it can't be equal to 0 this time. It also has to be greater than 0. So we're going to take what is underneath that radical and in that denominator, and we're going to say that we want it to be, it can't be equal to this time because we can't divide by 0, right? We want it to be greater than 0, all right? And so we're going to solve this one for x. So we'll subtract 14, and we're dividing by -2, which means our inequality is going to flip. So I need all values that are x's that are less than 7. So my domain is going to be x is less than 7. Oops. So that's going to be negative infinity up to 7, and it is not equal to 7, remember, because we can't be equal to 0 in that denominator there. And our last one here, another rational, and we're looking at what makes this equal to 0. So this one is already factored for us, so I'm just going to set it equal to 0, and then that's going to tell me x is equal to 4. So that means that I have to exclude 4 from my domain. So we're going to go negative infinity to 4, union 4 to infinity. All right, going on to the rest, the next part of this section is talking about operations with functions. All right, and mainly this is all just knowing the notation, knowing that if they put f plus g of x, that you're going to add function f to function g. Same for subtraction, multiplication, and division. All right, it says that the domain of f plus g and f minus g and f times g is the intersections of their domains. And then the domain of f divided by g is the intersections of the domain of f and g, for g cannot be equal to 0. Because remember, we cannot divide by 0 because that gives us something that is undefined. Oops. All right, so practicing a couple of these, doing some operations with these different functions. So they've given us two functions here. The first one tells us to do f plus g of 0. So based on what that rule says, it means to do f of 0 plus g of 0. All right, to figure out f of 0 means I want to plug in 0 for both x's in that function f. So we're going to have 0 squared minus 3 times 0. That's going to be 0 minus 0, which is 0. And then we'll do the same thing for function g. We'll plug in a 0 for that x there. And we're going to simplify that down, and it's going to get 5. And then ultimately we are adding those two things together. So 0 plus 5 is 5. F minus g of 4. F minus g of 4. So this really means f of 4 minus g of 4. So we're plugging in 4 into function f, and we're going to simplify it. And then we're going to do the same thing for function g. And ultimately, we're going to subtract whatever we get for both of these. So this is going to be, what, 16 minus 12, which is going to be 4. And this is going to be 16 plus 5, which is 21. So 4 minus 21 gives us a negative 17. All right. So you can just kind of see how these go. This one's going to be f of negative 2 times g of negative 2. And this one's going to be f of 3 divided by g of 3. All right, so you can go through and simplify those, and you can go onto the answer key there and check to see how you did on C and D. All right, so all of those were numeric answers. Now we're going to be looking at doing these for algebraic expressions. All right, so we're going to be looking at doing some of these with algebraic expressions. For letter A here, again, what does this notation tell us? It tells us to take function f and to add function g to it. So function f is 3x plus 4 plus function g is 2x squared minus 1. And so looking at what parts of these can we actually add together because they're like terms, that would be just the 4 and the negative 1 there. So 2x squared doesn't have a like term. Neither does 3x, but we can combine those. 4 minus 1 is going to make that plus 3. Next one, B. Again, this notation means f of x minus g of x. So we're going to have 3x plus 4 minus, now I will caution you when you're doing these subtraction ones, especially with these expressions, put that second expression in parentheses, all right? That's going to make sure that you remember to distribute that minus sign to both things on the inside there, and you get the correct signs for your polynomial. So I distributed there. Again, the only things that are like terms here are the 4 and the 1. So we go negative 2x squared, doesn't have a like term. 3x doesn't have a like term. And 4 plus 1 is going to make that 5. Okay, letter C, f times g. So again, what does that mean? Means multiply those functions together. So 3x plus 4 times 2x squared minus 1. All right, in this case, we're going to have to do the FOIL or the box method, whatever it is you prefer for multiplying your polynomials together. So let's see, this is going to be 3x times 2x squared. It's going to be 6x cubed. 3x times negative 1 is going to be negative 3x. 4 times 2x squared is going to be 8x squared. And then lastly, 4 times negative 1 is going to be negative 4. None of these are like terms, so I can't combine any of them together. But what I can do is reorder it so that it's in standard form, going from the highest exponent down to the lowest exponent. So that would be 6x cubed followed by 8x squared minus 3x minus 4. All right, and then our last one here, f divided by g of x means f of x divided by g of x. So that's going to be 3x plus 4 divided by 2x squared minus 1. Right, and there's not really anything we can do as far as actually simplifying it. This is as far as it goes. For this particular one, you might come across some that you could factor and something might cancel out. But in this case, that is not. But what we do need, and I set it up here in the beginning, is we need to find the domain for this one, because there is going to be some values here for which that denominator would be equal to 0. And we remember we can't have that. So I'm going to take that denominator and I'm going to set it equal to 0, and we're going to start solving it for x. So I'll add 1, divide by 2. Then to get rid of that square root, I'll take the square root of, or excuse me, get the squared, I'll take the square root of both sides. All right, which is going to give me plus or minus 1 over the square root of 2, but we can't leave that square root in the denominator, so we have to rationalize it by multiplying by the square root of 2 over 2, which ends up giving us square root of 2 over 2. So we have a domain here of x from negative infinity to negative square root of 2 over 2, union negative square root of 2 over 2 to square root of 2 over 2, union square root of 2 over 2 to infinity. All right, so anytime we have those rational functions, when you have a fraction like that, set those denominators equal to 0 and solve, and that's going to give you what you have to exclude from the domain of that function. All right, so you could also write that, let me get this. So you could say this is x cannot be equal to plus or minus square root of 2 over 2. All right, and the last part of this section is talking about compositions. So composing means to be putting something together, all right? So you can see the rules for each of these. So if it says f of g of x F of g of x means that g is the one that comes second, so its function is going to go inside of function f. And when we say inside of it, we're talking about like literally plugging it in for x. And then you've got g of f of x, so it's basically the opposite. Since f comes second, f would be the one that goes inside of function g, and that's a substitution there is what you're basically doing, substituting the second function into the first function and simplifying it down. So first one here, f of g of x, right? We're going to take function g and we're going to place it in place of x in that f function. So let's see, that's going to give us square root of 2x plus 5 minus 1. So we literally put that 2x plus 5 in place of the x in function f. And we're going to simplify this down. All right, 2x doesn't have a like term, but 5 minus 1, we can combine those, and that gives us 4. And so there is our composition for f of g of x. Part B, g of f of x, so we're going in reverse this time. So this time, this entire function is going to go in place of the x there. So let's see, what's that going to give us? So we're going to have 2 square root of x minus 1 plus 5. Right, and we aren't going to be able to really do any simplifying here, all right, because there's nothing that can really go into any of that. So we're just going to have 2 square root of x minus 1 plus 5. All right. This next one here is doing a composition, but also finding a value. All right, so you're doing f of g of 8. So we're going to figure out first what is g of 8 equal to. And then once we figure that out, then we'll plug that into function f. So f of g of 8. So let's do g of 8 means plugging in 8 into function g. So that's going to be what, 16 plus 5, so that's going to be 21. So now we're going to do f of 21. So let's see, 21 minus 1, that's going to be square root of 20, which I believe we can simplify back to from the first test. And this is going to be 2 square root of 5. And one more here, g of f of 5. Again, the one that comes second is the one you want to do first. So we're going to do f of 5. So f of 5 means plug in a 5 into function f. And we're going to simplify it down and get 2. And so then now we need to figure out what is g of 2. So 2 times 2 plus 5, that's going to be 4 plus 5, so we're looking at 9. Okay, and then these last two here, I am going to let you try those out on your own. And then check back with the answer key on Moodle to see how you do.